Good evening, all. Welcome to the fourth day program of online short-term course on Adaptation of Aquatic Systems to Climate Change. With the blessings of our beloved founder, Chancellor Colonel Dr. JPR Sir, I am happy to welcome you all. On behalf of Center for Ocean Research, we sincerely express our deepest thankfulness to our Honorable Chancellor Ma'am, Dr. Maria Zina Johnson, and our President Sir, Dr. Mary Johnson, for their constant guidance, support, and encouragement in all our activities. I also welcome our respected Director Ma'am, Dr. Sheila Rani Ma'am, Honorable guest Dr. A. Saleem Khan and Dr. E. Vivekanandan sir, respected advisor of Satyabama University TBI Dr. Sheshati sir, and our center head Dr. D. Inbakandan sir. Moving on to the technical session, today we have the guest speaker Dr. A. Saleem Khan. Dr. A. Saleem Khan is an interdisciplinary scholar in climate change. He holds his doctoral degree PhD in climate change adaptation from Center for Climate Change Adaptation and Disaster Management, Anna University, Chennai. He accomplished this Fulbright Nehru postdoctoral research at the Earth Institute, Columbia University, New York City, USA, and also his institute postdoctoral research at Indian Institute of Technology, Madras, Chennai, India, in climate change adaptation science and policy. He also served as a climate change program officer for the state of Tamil Nadu at the Department of Environment, Government of Tamil Nadu, Chennai, India. In addition, he worked as a senior scientist and research scientist at MS Swaminathan Research Foundation and Center for International Earth Science Information Network, Columbia University. Dr. Khan has published research papers in the context of climate change adaptation in peer-reviewed impact factor journals and the book chapters in the lead publishers. His research focus area includes climate change, sea level rise, impacts and vulnerability, post, urban, resilience, adaptation science, adaptation policy, and adaptation governance. And now the session is over to you, sir. Thank you.
Is my screen is visible?
Yes, sir, your screen is visible, but your voice is breaking, sir.
Sir, your voice is breaking. Dr. Saleem Khan, sir, your voice is breaking.
Is it audible now? Am I able
No, your voice is...
Voice is breaking,
Hello?
sir. I think so. There is some network issues in your side, sir.
Okay, give me a minute. I'll check my
Or you do one thing, if you have any network issues, you just send the PPT to me. I can navigate.
Can you hear me now?
Yes, sir. Now.
Yeah.
Okay, fine. Good evening, everybody. A couple of years before, I published a book chapter, and it was titled as Coffee and Planet. I think that sounds very much appropriate at this particular time, this evening. I'm sure you all will be enjoying with your cup of coffee, maybe tea, and I hope the climate will do justice from my end. I welcome you all for my session, and thanks to Dr. Inbakandan and his whole team from Satyabama University, and all the senior researchers and professors who are with me today. A very good evening, everybody. Last couple of days, I'm sure all of us are experiencing a different climate. It was very hot during the daytime, but it was raining so badly in the evening and the nights. This is what my daughter asked me. Dad, like the climate is so cold in the night. I always used to narrate this in the very first presentation, very first slide of mine from my daughter, because she questioned me, the climate is so hot today. Last night she was asking me, the climate is so cold today. I used to teach her, it is not climate today, it is a weather today. So I welcome you all with the basic understanding the difference between a weather and climate. And I have structured my presentation to engage with you all for the next 45 minutes to 60 minutes roughly in this order. I'm sure last 3 days you must be loaded with different or too many information related to climate change, whereas I'm just going to just skim read the basics of climate, and then we'll switch forward to sea level rise. That's where I am more interested in. And let's see some few case studies across the globe, what they are doing to adapt to rising sea level. And I hope I make you all to go home with some take-home messages. As I said before, the weather is different and climate is different. If you're talking about atmospheric change of a particular period, which may be a few hours, a day, or a couple of days, or even a fortnight, it's called weather. According to the Intergovernmental Panel on Climate Change, to define climate, we should have a weather data for at least 30 years. For example, if you want to know the climate of Chennai or climate of any part of the world, you should have at least 30 years of data. That is 30 years of daily or annual temperature parameters or precipitation parameters or whatever the climate variables you take, and draw a graph for that 30 years. You may get an observation, the graph may go up, the graph may go down. Then you say the climate has been changed or the temperature has been changed. So the message here is, if somebody asks you or tell you, or even you tell, the climate is good today, bad today, please stop them. It is not a climate, it is weather. The weather is good today, the weather is bad today, the weather is chill today. You phrase it the way you want. This is called a word cloud. I'm sure this is a basic uh, word play game that anybody could play. But the words here used, or all the synonyms that we come across in the context of climate change. But I would like to highlight one particular word, which is called anthropogenic. The climate which we are talking about is about man-made or man-induced changes. Because there was another day, one of the students asked me, if there is no climate change in real, then what we are talking about? There are two different changes. One, by natural way itself, the climate is changing, which is beyond the human limits. But we are not talking about that. The IPCC clearly defines the climate change that we are addressing as anthropogenic induced changing climate. This particular slide, that man-induced changing climate, that you all know that the global warming is due to the emission of greenhouse gases in the atmosphere, and because of that the temperature increases and in turn the climate is changing. Before we get into the deep subject, I would like all of you to take some keywords with you to go along with me. One of the keywords is impacts. Impact is nothing but one or something that attacks you. For example, if I am healthy or I'm just standing, the malaria comes and attacks me. So now the impact here is the malaria. Likewise, the climate is impacting different systems across the earth. For your kind information, the climate, if we say, we all know only temperature, precipitation, or relative humidity, wind. To best of my knowledge, there are more than 171 climate parameters out there. If we go and see the manual of climate model from the UK Hadley Center, they have given a list of more than 171 climate variables. It is not just temperature, sea level rise, and precipitation. Well, each of these climate parameters has its own influence on different systems across there. It may be an agricultural system, or a coastal system, a forest system, or anything you name it. Each parameter has its own influence, and that's what we say climate is a complex. If you want to study climate, it is not that easy because it is a complex process and its influences is very difficult to understand because one interacts with the other. Let's not get into details of that, but the word here to keep it in mind is the impact. And the next is vulnerability. These slides look a little more academic. Let's not get panicked with the equations. It's just for you to understand what vulnerability means. In climate science class, this is what we have been taught. Vulnerability is equal to exposure plus sensitivity plus adaptive capacity. Exposure, for example, I am living in the coast of Chennai, but not entire coast of Chennai is exposed to sea level rise. The coasts that are low lying are exposed. So here the point is low lying. Those who are at low lying, they are high exposure. Then sensitivity. I have a strong building in the low lying area, then I am strong. If I have a very weak building, the construction is weaker, then I'm highly sensitive. So that favors me to get impacted by the sea level rise. And third is the adaptive capacity. Some places we have a good coping capacity. For example, in the again low-lying coast of Chennai, we have a community, they are living in the slum. Few kilometers away, same low-lying area, we have a high-rise building. They are also a community, but they are financially stronger. The adaptive capacity of these two communities in the context of economics is different. Those who are economically sound, they have a good adaptive capacity or the coping capacity. Based on all these three parameters, exposure and sensitivity and adaptive capacity, we can determine a vulnerability of a place or a community or a system. So if the system is vulnerable, weaker, the impact will be more. That's what you see in your any of the research papers. They come with the classification of vulnerability as high, medium, and low. Those who are highly weak, they are highly vulnerable. Those who are stronger, they are less vulnerable. So we can tweak these vulnerability understanding on each subject, whichever we want. In case of climate change of coast, we say elevation plays a big role. Those who are at a high elevation, they are less vulnerable. Those who are at the low elevation, they are highly vulnerable. This is just for your understanding. Well, if there is a changing climate and it impacts different systems, and some systems are vulnerable to those impacts, the best way to address these impacts either mitigation or adaptation. Mitigation is a process to stop, in other words, to control. Certain things we cannot stop, we have to adjust with it, and that is called adaptation. For example, if we want to stop emitting the greenhouse gas in the atmosphere, it may be possible. If you go green, if you go for sustainable strategies, or if you go for alternative technologies that reduce the emission of greenhouse gases, you may be able to stop. But even if you stop emitting the greenhouse gases, the melting of glaciers and ice may result in rising sea level. But you cannot go to the Marina Beach and say, don't rise my sea level. It's not possible. But we can adapt to those changes. Either we can construct a seawall or we can go away from that place. There are different methods. The Charles Darwin once said, who is called father of evolution or origin of species. That's the book he written. In Tamil, he said, I just translate in Tamil, I then go back to English. எந்த ஒரு உயிர் மாற்றத்திற்கு ஏற்ப தன்னை மாற்றிக்கொள்கிறதோ அந்த ஒரு உயிர் மட்டுமே நிலைக்கும். An organism that has an ability to change itself can survive. He said this number of years ago, and that is called adaptation. The process of adjustment to actual or expected climate and its effect. In this case, climate. In simple words, we can say ability to adjust. So Darwin said this many years ago, and today it's become an integral part of climate change response strategies, that is adaptation. We may have some ability and we need to identify those ability and strengthen them so that we can adjust or adapt to the changing climate. Many ask us, because I always advocate for adaptation. They say like, why you talk about adaptation? Why not mitigation? I'm not against the mitigation, but mitigation is a different process. Whereas adaptation has its own merits, and my job is to advocate for the sake of adaptation. And we focus adaptation for three major reasons. One, we can do adaptation efforts immediately. For example, you want to construct a seawall, or you want to uh, construct a structure. You can start the very next day, provided if you have enough fund, provided you have enough designs to implement those ideas. But if you want to stop the carbon emission, it is not just you. It is a global process. It is not just India. It is the entire world. Unless we entire world stop the emission of greenhouse gases, then only we can mitigate it. Whereas adaptation is not like that. It is up to a particular state or a local or a community or even an individual. It is their decision. If they have the potential, they can do it. So it is an immediate effect we can see in adaptation. And second, as I said earlier, mitigation is a global process. It requires a global commitment, and that's what we have come across COP15 Copenhagen Accord in Copenhagen, Denmark in 2009. We have COP17 Durban, South Africa, and COP18 at Doha, Qatar, COP21 at Paris Agreement. All these climate change conference of parties highly talks about the mitigation perspective, just to bring a consensus of the global countries to a common ground. And these days, after COP15 at Copenhagen, adaptation takes its own dimension, and it's gaining more attention as well. Another good advantage with adaptation is it always play a co-benefit. Means you don't need, if you're planning for adaptation strategy today, it not only helps for your 100 years plan, and after 100 years sea level will rise, so I am constructing a seawall. It also addressed that, but it also addressed today's issue. If there is a cyclone that hits the coast next year or next month, still your adaptation measures addresses that issues as well. So it reduces the risk associated with current climate variability as well. So these are the three main reasons that we focus on adaptation. So the first segment, I just introduced you all weather, climate, climate change, impact, vulnerability, mitigation, and adaptation. Now let's get into specific on coastal system. We're all aware coastal is an area where the land and the sea meets. We know that the coastal and marine system are useful in different forms. They are biologically rich, they're environmentally amazing, economically sound, socially healthy. We cannot ignore coast. Unless 1991, when the coastal regulation zone was came into picture, we treated coast in a different way. In fact, not many noticed coast as an asset, until other than the fishing community. But today we have a strong coastal management system. There are a lot of coastal regulation zone activities. There are a lot of rules, laws, policies related to coast. And we have grown up in the last 25 to 30 years a strong coastal management, particularly in concern with the coast of India. As I said earlier, there are a number of climate variables, and each climate variable impacts the coastal system. It impacts on its geographical location based on its elevation, or it may impact on its physical structures. In Tamil Nadu, if you take across the coast of Tamil Nadu, we recently worked with Ennur coast in North Chennai. It's fully loaded with industries. We have number of power plants. We have cement industry there. we still have a fishing communities there and a remnant of mangroves. It is a very complex system, of course. There you find a physical structure, which means the power plants that located there is like huge and mega structure, and that has its own threat in front of rising sea level. When you go down south from Chennai and north to Kadalur, you find Pichavaram mangroves, and further down you find Muthupet mangroves. They are the ecosystems. They act as a protective barrier, particularly during the coastal disasters. So these ecosystems are also influenced by the changing climate in general and rising sea level in particular. Likewise, the community that live across the coast, we have fishing community, we have salt pan workers, some people who depend on the coral reefs. All these livelihood are highly questionable if there is just a rise of 1 meter sea level. To make a clear picture, to make you all little understand what are the causes for sea level, there are only three major reasons. One, thermal expansion of seawater. The water body in the ocean has a huge absorption capacity, so that makes the thermal expansion across the ocean. And two, melting of ice. That we all aware, the Arctic and Antarctic. Those ice melts that increase the volume of the water. And third, the hidden secret. Once you dig out the water in the area that are close to sea, you may get the threat of saltwater intrusion. That's what they mentioned, changes in amount of water stored on land. Usually we have aquifers on the coastal area. So that the over digging of these water level may favors the salt water from the sea to come in and penetrate in, and that may leads to seawater intrusion on the land. So these are the three prime reasons, along with many other reasons, that results in rising sea level. Usually, how do we know the sea level is increased or not? This is just a picture that tells you how we can measure sea level. This is called tide gauge station. Like how we have rain gauge station, we have tide gauge stations, which we can see in many ports. That measure sea level, which is increased or decreased from the mean sea level. So mean sea level is an average of the high tide and the low tide. For your kind information, somebody who wants to learn or explore more in sea level, you can visit a website called PSMSL, Permanent Service for Mean Sea Level. If you get into that website, that gives 100 years of data of your tidal data of any tidal stations that are listed in that list. For example, if you want to know whether the sea level has been increased in Tamil Nadu coast or not, if you go into that website, you find 4 or 5 tidal stations there. One of them is Chennai station. Chennai station have a data for 100 years with some data gap, and that will give a graph. And that graph says there is 0.3 millimeter rise in sea level every year, which is on the positive trend, which means rising trend, but it is not that alarming like any other city like New York City, where sea level in the past is rising rapidly. Whereas here, it is rising, but not very rapidly, but in the positive trend. So these kind of information of a past sea level, you can get it from tide gauge station. And once you get the past sea level, let us assume I want to know the sea level of Chennai or Tamil Nadu. So first thing is I need to know coast of Tamil Nadu, coast of Chennai. Then I want to know the past sea level trend of Chennai, which I've said PSMSL data can help you. And second, we want to know what will be the future projection of sea level. As you all aware, we today use different climate models to give future projections. There are different methods to do modeling. Some of them are downscaling method. In that, they have statistical downscaling, dynamic downscaling. We also have a pattern scaling technique. What all these model does, they take global climate data, they work with the principle of physics, maths, and different algorithms. If you get in touch with the climate modeler, he will explain more detail how it functions. Whereas people like me are climate model users. So we are not bothered how it is constructed, but we are more concerned about how best we can make use of those models. With the help of downscaling, we can give future projection for our own study area, how much it may rise. So global mean sea level projection by the IPCC is roughly 0.5 meter to 1 meter sea level rise. So if there is a 0.5 or 1 meter, let us assume, in fact, we published one of our papers in Journal of Coastal Conservation, which is 2017. That talks about local level sea level projections for each districts of Tamil Nadu, from Chennai to Kanyakumari, along with Puducherry, Indian Territory. So that, on the whole, it says Tamil Nadu may experience sea level rise on high estimate scenario, maybe from 0.25 meter to 0.75 meter. You may wonder, it is just 1 meter, which is 75 centimeter or 50 centimeter, which is like if you take a ruler, a scale, it is just the size. But to be very honest, on ground, when you measure the elevation from the mean sea level and you superimpose this sea level projection of 0.5 meter or 1 meter sea level rise, it may inundate enormous amount of low-lying areas on the coast. And that is going to be a big threat for the entire coastal regions, coastal resources, coastal wealth, coastal communities across the planet in general and India in particular. All the coastal areas may be vulnerable, and we need to figure it out who are more vulnerable and who are less vulnerable. And this circular diagrams give some of the major impacts on coastal system in particular. It may lead to increased coastal flooding because of rising sea level. Salt water may intrude. Beach erosion may occur. There are a lot of wetlands that exist across the coast. In Chennai, we have Pallikarne marshland. In, as I said, Pichavaram, we have Pichavaram mangroves. They all act as a protective barrier. So when 2004, when tsunami struck the coast of Tamil Nadu, we have a very different story. From Pichavaram, few kilometers down south, we have Nagapattinam, and that was worst hit during tsunami. Whereas the few kilometers away, Pichavaram was less attacked. Later, the scientists come to a conclusion it may be because of mangroves that acted as a protective bioshield, so that the casualties were very less in Pichavaram or around Pichavaram when compared to Nagapattinam, which was just an open land that exposed to sea. So these wetlands act as a buffer. Because of sea level rise, these wetlands may be also under threat. In mangroves, they breed through nematophores. Scientists suspect that because of rise of sea level, these breathing roots may inundate in water, and these mangroves may not able to breathe and may not able to survive, particularly the juvenile mangroves. Likewise, it may also create many other impact on the coast. Like we have a good tourism across the coastal area, the tourism may be affected. A lot of fishing communities there. We have a communities called Irulas, which we come across. They do hand picking in the coastal area, particularly in the backwaters. So the survival of those indigenous or the native fishers are highly questionable if there is a sea level rise. It may be very fancy to talk about climate change for people like me to sit somewhere else and tell this is the climate model, this is the future of sea level, this is the impact. To be very honest, it may be easy for me to sit and talk from here, but to be very honest, the Irulas and the fishing community who live somewhere in Ennur, who live somewhere in Pichavaram or somewhere in Kanyakumari, they are the first one who gonna face the threat of rising sea level. It is neither you nor me, but we talk more about climate. So that's what we believe. A strong communication network should be established to exchange the information of scientific community's perspective on climate change and pass on to them, and also get the knowledge from indigenous community. Do they have any coping strategies or adaptive strategies among themselves? Because they are the custodians of the area, they are the better scientists, they know how to manage the sea. So we want to integrate the scientific as well as the indigenous knowledge in the decision making plan. And that is one of our ultimate objectives of addressing sea level rise. As I said, we can learn the past sea level through sea level trend through PSMSL data and future sea level by climate model. And we can also assess the impact. I said number of impacts. There are many methods to do the impact and vulnerability assessment. One of the methods is GIS platform. You superimpose your satellite images with the sea level rise projection. You may be able to identify the area that are vulnerable or people that are vulnerable. And finally, this is what most important. Once we identify these are the people, these are the regions, or these are the ecosystem that are going to be affected by sea level rise, then what we need to do. IPCC recommend three major principles. One is called retreat, another is called accommodate, and third is called protect. Retreat is you move away from that place. There is a threat in front of you. This picture says you see a down arrow coming up, that is rising sea level. In the first diagram, you find a house with an arrow which moves forward from the sea. So that is one way you move away from the threat. That is called retreat. Another is accommodation. You don't move, you still stay there and you're ready to face the threat. Second picture you see, the house has been elevated up. And that is called accommodation. And third is protect. You create a new structure in between the rising sea level and your property and your assets. That's what we said, like seawall is a good example. So that is called protection. Wherever you go across the globe, if you want to address sea level rise and coastal adaptation, they broadly work under this philosophy of retreat, accommodate, and protect. They choose either one of these options. And that's how the adaptation principles on the coast works on. To give some examples how these protect, retreat, and accommodate work, I would like to give you some case studies. One on cities and a big area where populations are heavy, another on rural area. This map gives a good indicator. There are different cities across the world, from New York to London to Jerusalem, Chennai, Mumbai, Karachi, Jakarta, Bangkok, Dhaka. These are the big cities that are at the risk to rising sea level. Now, big cities are given more concentration, mainly because they are densely populated, heavy infrastructure, lot of economy. And that's what cities are given more priority. On the other hand, cities can do a number of activities immediately because there are a lot of infrastructures available, a lot of money is rolling around, a lot of potential is there compared to the other areas. So cities can be a forefront runner to showcase the adaptation or a mitigation strategies to the rest of the world to inspire and do it. And that's the reason many of the activities they concentrate more on cities so that they can see the outcome. Likewise, it doesn't mean that cities are given priority so the other areas are not. Certainly, many of the ecosystems are mostly out of cities. In our case, even if you take Pichavaram, it is not in the city limit. It is not in the city. It is an urban, rural area. But still, we need to give attention. Let's see how the adaptation works with some of the case studies here. There are different types of adaptations, but the approach they usually apply in the adaptation fraternity is infrastructure-based adaptation, ecosystem-based adaptation, and community-based adaptation. I'm sure earlier speaker yesterday and day before yesterday, they have addressed this issue, infrastructure and ecosystem-based adaptation. Maybe I just throw some lights on it. This one example is a promising one to show even many of the conference of parties, if you go, you can see this display. This is Thames Barrier in London. It is actually constructed as a coastal flooding infrastructure. But now it is considered as one of the promising structure to address sea level rise. So this is an engineering-based structure which requires a lot of investment in the form of materials. So the word engineering and infrastructure itself justified. It is a megastructure with the concretes and steels. When the Thames River floods or the sea level increase, this barrier is like kind of a shutter. These shutters do not allow the water to come inside the London city. As a result, 1.25 million people, nearly 200 billion pounds of economy are protected. So that is how these big cities are coming up with the new mega and big ideas, how one could protect the area from rising sea level. Another example is Netherlands. Maesteland barrier is another amazing marvelous that talks about similar to Thames barrier, not to allow water to come inside Netherlands. So this again a concrete structure with steels and cements and different engineering processes. So scientists of engineering background, they come up with these kind of structures still in the context of adaptation. Let's see some weird engineering structure that has been proposed. Rotterdam floating pavilion, which you see in the downstairs like a ball, it has been displayed stating that it is actually a pavilion. They conducted one of the climate conference side events there. And the objective is in future, they want to construct a floating island so that when the sea level increase, the island also goes up. When the sea level goes down, the island also goes down. So it is a weird thought, but it is that's how the human mind works. The engineering mind of human being works. It is one of the attempt to address sea level rise. And on top of it, you find giant wall of Jakarta. Now it is in progress. They plan to finish the work by 2025. So they want to construct a big wall across Jakarta so that the water don't engulf into Jakarta cities and the small islands that located across Jakarta. And this plan is already approved. It is on ground. It is in process. By 2025, we may able to see the Great Wall of Jakarta like Great Wall of China, which we know one of the wonders. The same idea has been proposed for Manhattan as well. Manhattan is in New York City. It is at the zero level elevation. You all know New York City is very world famous city center. Surprisingly, it is at the zero level. New York, Manhattan, and the Hudson River are at zero level. If there is small rise in water, no matter sea level rise, just a small rise in water for some phenomena, the entire Manhattan city will go underwater. That they have experienced in Sandy, Superstorm Sandy in 2012. We thought New York is superpower, and these are greatly built cities, but they failed in 2012. But after 2012, they waken up, they came up with a lot of ideas. Now they are ready to face any kind of threat due to coast in general and sea level rise in particular. Here that one idea is Great Wall of Manhattan. They want to construct a great wall, a big wall across the Manhattan area, so that, like a sea wall, so that they can protect the Manhattan city. It is still under the proposal of the mayor's office. It is not yet approved, but the discussions are going on. What will be the benefits and constraints and challenges due to this proposal? Another is ecosystem-based adaptation. I take this example of New York again because I did my research there, so I prefer to give that experience to you. Like how I said, Pallikarni marshland in Chennai, there they have something called Jamaica Bay. Jamaica Bay is a marshland or a wetland located near John F. Kennedy Airport. Where the first picture you can see the wetland. On backdrop, you can see the skyscrapers. So it is a part of the city. Now, they say or they believe if we protect this Jamaica Bay, they can protect half of New York City because this acts as a buffer. Like how I said an example for Pichavaram mangroves, how it protected the Kadalur district during tsunami, but not Nagapattinam. Likewise, restoring or protecting this Jamaica Bay will act as a protective barrier to protect New York City from rising sea level. So here the marshland or the wetland ecosystem plays a big role. And this is one of the strategies they want to adapt. So I'm not getting into the techniques, how they restore the ecosystem, because that is a different science. There are a number of restoration techniques. In Pichavaram, we use fish bone structure or landward migration of mangroves. That helps to restore mangroves. Likewise, in Jamaica Bay, they have restoration methods to restore the mangroves. But the point here to understand is, if we protect this ecosystem, we may able to protect the coastal system that lying beneath on it from the rising sea level. This is a world famous example, Sundarbans mangrove, which is shared by India and Bangladesh. We all know mangrove play a big role. I have put tiger picture here. Recently, I came across a paper that topic itself, sea level rise, mangroves, and tigers. It was very fascinating to read the paper because it showed in that paper they have identified low-lying mangrove areas in one map, whereas in other maps they identified the tiger-dwelling hotspots. Then they merged both the maps, and it gives a picture. The low-lying, there are some spots that matches. So tigers in the low-lying mangrove area are at high risk. It is one of the very good new thought. We always talk about man ecosystem and tiger like nobody dare to touch it. But that paper, it is I think it is partially done by WWF. It was very interesting. So now we even look for a wildlife conservation through the ecosystem-based adaptation. So this is another example. And in all these examples, I gave a YouTube link that will give you more detailed, interesting field to explore much further. You can explore that. I have a few more slides, then we get into discussions. The last is community-based adaptation. Once we visited to Bangladesh, we asked one of the farmers, his agricultural land was close to sea. Earlier, he used to do some agricultural practice. Because of saltwater intrusion and also flooding, his area was fully flooded. We asked them, those small community, to migrate from that area to elevated area. He asked one question in written. He asked us, do you go away from your home? And we all were speechless. We written back and we do not know how to address this issue. Then we again went. We wanted to know more from him, how he can cope. So he came up with this idea called floating agriculture or floating garden. It is one of the accommodation strategy. You remember there were three strategies: protect, retreat, and accommodate. Accommodate, there is a threat is there, but still you live in with that threat. So he still lives in that flooded area and salt included area, but he can ensure his livelihood there. He introduced this concept of floating agriculture with the help of bamboo sticks and with native coconut pots and coir. He made this platform and started growing fruits and vegetables that may able to grow in that condition. And he able to grow vegetables and food and make his livelihood. And that is the success. And this is very popular. And even in India, we started practicing these kind of floating agriculture as one of the adaptive strategies to rising sea level. The last one is Chilka Lagoon. I'm sure many of you have done your researches or even field visits to this place. It is an amazing spot where you find a lot of fishes. This study was done by one of the groups to ensure the livelihood of the people. So community-based adaptation here also refers to building the capacity of the people. The fishing communities plays a big role, and this particular study focused on women, how women plays a big role, and how one should ensure the capacity of the women to take a decision. So they took all the women fishing communities as well as the men in planning the adaptation strategies to sea level rise. So if you get into the field of adaptation and community-based adaptation, and this is also considered as one of the adaptive strategies, like we say soft adaptation, making people understand, making people to equip, or making people to take decision. In simple word, we say building capacity. All these factors ensure that we can adapt to rising sea level. It could be through engineering way, or it could be through ecosystem way, or it could be through community way. I stop here with this alarming note. I talked so much about adaptation to sea level rise. One may have a question like this. What if there is no sea level rise? What if your climate model may go wrong? What is the confidence on it? And that's where this picture, this keyword comes, maladaptation. Maladaptation is adaptation if it goes wrong. Then it is called as maladaptation. Action that may lead to increased risk of adverse climate-related outcome. In result, it increases the vulnerability. Let us not get into definition, but the key word is what if it goes wrong? That's what many of the climate managers, they advocate for mainstreaming adaptation strategies, which means whenever you plan for an adaptation, make sure it goes in line with your sustainable development principle. I'll give you an example and stop here. Let us take the same picture of mangroves. I, as a scientist, say in 2050-75, there will be a 0.5 meter sea level rise. If there is a sea level rise, mangroves may inundate. So let us restore mangroves. So I get fund from Ministry of Environment, from 50 crore. I invest my money in restoration of mangroves. Let us assume it is not the same sea level rise as I quoted in future. Instead of 0.5 meter, it was just 0.2 meter. So you may ask, what happens to all the 50 crore money? That is what they say, do it mainstreaming. Here mainstreaming refers to sustainable developmental goals. Even if sea level is not increasing, even if this mangrove is not addressing the adaptation, but still it can help the Irula community to ensure their livelihood by having the fish hunting in the backwaters of mangrove. Now, ensuring the livelihood comes under the sustainable development principle. Adapting to sea level rise comes to a sea level or climate change strategy. So whenever you make a climate change strategy, make sure you integrate or mainstream with the sustainable developmental goal so that it will be a co-benefit. Even if one fails, it helps the other one. I hope this presentation is maybe a little lengthy or even technical, I do not know, but I am confident you go with this 5 take-home messages. 1, if you want to address climate change, keep these keywords in mind from the basic weather, climate, impact, vulnerability, mitigation, adaptation. The keywords is your first take-home message. And two, if you want to address sea level rise, you have to explore more on past sea level trend, future sea level projection based on model, and how to do an impact and vulnerability assessment, and how you can adapt to changing sea level through protect, retreat, and perform. In simple, understand the science of sea level rise. And third, these case studies may be interesting for you to keep it in mind. Thames River, New York City, Bangladesh tiger. So these examples, you can just put it in your mind. So it helps you to rewind once you go back. And finally, maladaptation. What if anything goes wrong in your adaptation process? That keyword is called maladaptation. I don't want to get in details of maladaptation because that is a big one. But I want you to understand whenever you prepare for success, one should also prepare for a failure. Whenever you prepare for maladaptation, you should also know what is maladaptation. So I stop with this and I am happy to hear more from you guys if there are any questions.
Thank you, sir. Thank you for
Thank
your
you, sir.
wonderful presentation.
Thank you, sir.
Thank you.
Dr. Vivekanandan sir is here and Dr. Shashatri sir is also here. Sir, Vivekanandan sir, we want to hear from you, sir.
Okay. Uh, okay. Thank you very much, Dr. Saleem Khan.
Thank you.
It was extremely nice presentation. It was very clear, and you not only clear, you made it very simple for everybody to understand. Because I know the sea level rise science is very complicated, and you made it very clear for everybody to understand. And I do not have any question to you, but from your presentation, what I would like to inform the audience to, and also make them think about it is that you have shown different case studies, different options that are available, but it is going to be very, very expensive for the government when you start adapting to that. My worry is our government really sensitized about it? Because this is going to happen sooner or later, maybe sooner in some locations, later in some other locations. And we need to have a proper planning for that. Because there are some soft options, there are some hard options. Some places, as you said, may require some soft options like Pichavaram and things like that. You go for hard options, construction of sea walls. In fact, I have seen, we have also shown some slides in Netherlands and Norway. They are constructing their makeshift houses in the sea itself. So when the sea level rises, the house also rises. So these are engineering marvels, I should say. But these are very expensive models. And even sea wall construction is going to obstruct the traffic between the land and the sea. For example, the fishermen will be affected. They cannot reach the sea. They have to go around in a circuitous route, 2 kilometers, 3 kilometers. So these are very many challenges that is there. Is the government really sensitized about it? Do we need to have a sort of a proper planning, as these are the areas which are going to be very vulnerable, these are the areas which may not be. So what type of action we are going to take based on the prevailing environment, ecosystem, and also fund availability. I think this sort of sensitization has to come first to the government, and it has to come from the local people only. It has to come from the local people. And I think it's a very big task in front of the government. And I think you have made this point very clear. And maybe I don't know whether the government has really thought about thinking seriously about sea level rise, which is very, very important in the present context. Thank you very much for very nice presentation. Very much I appreciate your presentation. Thank you very much.
Thank you so much, sir. I would like to take just a couple of minutes to just respond to sir's statement. Yes, government is aware of this issue, but the answer is yes. But is it enough? The answer is no. So we need to do a lot many things. For example, we have National Action Plan on Climate Change as well as State Action Plan on Climate Change. At policy level, we have agendas and projects and programs. There are something fund mechanism called GCF, Green Climate Fund, and something called Adaptation Fund, and also called National Adaptation Fund. So these are the funding mechanism that helps to derive fund from the national government to the state level to implement these kind of adaptation projects. When I worked as a climate change program officer for the government of Tamil Nadu, so I played one of the roles to seek fund from the union government for coral rehabilitation in Tuticorin with the help of one island, which is located somewhere in Tuticorin. So we want to protect and artificially rehabilitate the corals. So that was the fund actually came from National Adaptation Fund. So the message here is, yes, we are aware, the government is aware, government is doing, but we have long way to go. We have so much to do. It is already a complex and intricate subject and intricate way to address it. Maybe experienced persons like you can advise young guys like me to work more effectively and can address this issue collectively with the support of the government. I'm hoping for that.
Thank you, sir.
Sheshatri sir?
That's wonderful. I don't have any extra words to say than Professor Vivekanandan's. Well, I don't know if there is an incidental thing or not. I just moved from Kotrapuram to Gandhinagar. You hope you know the topography of the area. 2 days back, I'm just trying to rearrange my books. I had today only morning only I chanced upon bumping on this book compiled by Indo-Global Social Service Society, written by Sanjay Katua. A very interesting booklet.
Sir, sorry to interrupt, sir. Sheshatri sir, your voice is not audible. Yeah.
Is it fine now?
Yeah, yes,
Yes,
yes.
sir.
Yeah. Today, just while I was rearranging all my books, I could able to go through one book written by this, compiled by this group called Indo-Global Social Service Society, and the work done by this Sanjay Katua under this Pearl program, they call it as. In fact, they captured West Bengal, Orissa, and Andhra Pradesh. Interestingly, almost whatever given by Dr. Saleem has almost captured wonderfully there, and he is talking about this Tamil Nadu examples. The wonderful thing. And interestingly, they also captured some of the community, because you were talking about community level initiatives. That's a wonderful thing. They also talked about this, especially more than projection, they also talked about this community driven activities, right from growing prosopis, even rope making, to even growing cactus, casuarina, cashew nuts, and many things they have projected as one of the, as I mean, part of the changes that's happening in the coastal ecosystem. Even from they have even captured some of the things almost related to growing grasses also, if I'm right. I mean, the new kind of grasses, nalia or something like that, and even pongamia. That's wonderful. There are, I mean, community-led examples, and even there are opportunities for us also to identify lot of new things from happening in the ecosystem adopted by communities itself. That's a wonderful thing. And in fact, Dr. Saleem has captured everything nicely, and it is wonderful to watch that. And it was almost like a classroom. He was very patiently providing all kind of information, very diligently. Wonderful. I hope everybody would have enjoyed the lecture today. I think we have to continue these discussions, especially in terms of this vulnerability area. Interestingly, of course, I do not know much about the rivers of Tamil Nadu, But in Andhra Pradesh, you might have, in Tamil Nadu, in India, it is Ganges is the one given a bigger threat as the most important one. Next to that, it is Godavari. And of course, other things also projected there. And Tamil Nadu, as we know very well, that there are incursions happening due to port expansion, all these things. So one thing, and there are other climate-related problems. Maybe it's good we discuss continuously, because they are also, IIT is very closer. We can discuss with them also see how best we can try to come up with kind of solutions to localized problems. Thank you so much.
Thank you,
Wonderful.
sir.
Thank you, sir.
Thank you. Thank you.
Dr. Jayakumar is raising his hand, sir.
Yes, sir, I have unmuted him. Yes, sir,
Dr.
Jayakumar, sir.
Yes, Dr. Saleem sir, this is Jay
Yes,
Kumar.
sir.
It was nice presentations I had today, and it was informative as well. So I have a few questions regarding your climate change models. What are the standard models you are using? Because a few studies says the some variation, sea level rise in meters, millimeters. So and a few are different compared to others. So that thing I wanted to know. And in addition to that, you were talking about bioshields, especially mangroves. And mangroves are very apt suitable in the creek, bay, and the tidal zones. But no, some area where we don't have a mudflats area, we will go with non-mangroves. So that is also difficult when we don't have lands, lands. Some of the lands owned by the local community, and a few of some places the government. So where maintenance and the restoring of restorations and affairs of non-mangroves also difficult. So is there any good suggestion from you, sir?
Answer to your first question related to climate modeling.
Okay.
Yes, there are uncertainties with model. So one may not know which could be a best model to choose it. But there is a method called multi-model ensemble, which means you take the output of different global circulation models and you arrange it together. Here we use a technique called pattern scaling technique. So that take an average of all these models, whichever you feel it may be appropriate. So you may not able to choose one particular model, rather you take a set of models and using a pattern scaling technique, you can take an average of those models and represent. That's one way. Usually, if you even any kind of climate models like PRICE, providing regional climate for impact studies, that is developed by UK Hadley Met Office Center, or even US model or Australian model. All these work under principles recently by using different general circulation model. So you pull out so many general circulation model on downscale to local level. In that way, you may able to have some hope. The outputs of model may be more appropriate, which we say how to address the uncertainty of the model. Hope I have answered your first question.
Yeah. Thank you, sir. Thank you.
And second, as you said, that mangroves are mostly favorable in the estuarine area, wherever the fresh water meets the salt water. It is typically an estuarine region. Other than the estuarine, even in Chennai, we can see at Adyar River, the river Adyar connects to Bay of Bengal. There you find some remnants of mangroves even today, near to Adyar Theosophical Society. But if you go and see at Kuvam River, that is Napier Bridge, there also the Kuvam River connects to Chennai, Bay of Bengal, but you don't see mangroves there.
Exactly.
But the condition is not favorable. So as you said, mangrove may not grow everywhere except those favorable estuarine regions. But other than mangroves, that bioshield complex itself, I think Dr. V. Selvam from MS Swaminathan Research Center has published a book in the name of bioshield. If you explore that book, you may come to know what are the different options other than mangroves that we can choose for coastal bioshield. It is very subjective. The answer to your question is, it is subjective. Whatever the area you choose it, other than mangroves, we can choose casuarina or we can choose coconut, which can protect as a bioshell. That may be differ because of number of reasons. There may be some constraints. That's what I said in adaptation. Whenever we make an adaptation plan, we should also create a column for opportunities, threat, and constraint. It's not possible, everything is possible everywhere. So we can try for option of casuarina, but there may be a constraint. It may not possible to grow. The environment may not support, or there may be no space, or there may be not even a fund to put casuarina. So in that option, we have to go to the next option. There, they introduce a one context called biosaline agriculture. Maybe Dr. Velvili, day after tomorrow, will talk about that. Even on the plain land, saline tolerant land, instead of just leaving the land vacant or wasted, we can grow some kind of crops that are salt tolerant. So that one or the other way act as a beneficial activity on the coastal area. So likewise, my answer to your question is, it is very subjective. We need to explore what is possible ecosystem or the methods that is suitable for that particular place, and what are the constraints and challenges. Then we can come to a conclusion, this may be possible or not. Did I answer your question, Professor?
Yeah, sir. Yeah, sir. Thank you so much.
Actually, Dr. Jay Kumar, he is from Tamil Nadu State Disaster Management Authority.
Okay.
Okay.
He knows
So I'm
very well
talking
about me,
to
sir.
Sir?
Dr. Jay Kumar M. S. Swaminathan. I
Okay.
hope you wait
Oh
for
yeah.
that.
Of course, I understand. Okay, I know very well.
Yeah.
He was my colleague.
Yeah.
Okay.
Thank you. It was
Talking to you, Doctor. Yeah.
I think R.K.
Hello.
Sarangi.
Yes, sir. R.K. Sarangi sir is unmuted.
Good evening to all, and it's a nice talk by and a nice topic by Dr. Salim, and nice talk on the sea level rise, very important phenomenon, globally challenging topic. So I have questions regarding how this sea level rise can be minimized, and what are the initiatives are being taken up in national and international level. So I have one or two more queries also there. So another, I think I should I ask now itself, should I ask, or I can ask?
Yeah. You can go ahead. You can go ahead.
Yeah. And second is, what are the level of measured sea level rise in last 50 years or in a century, a decade? Is it on record, or is it standardized by different methods? Previously it may be used by these tidal gauges, and now this a lot of models and advancement have come, satellite data, sea surface height, altimeters, OGCM model, and several advancements have come recently. And so is it standardized methods, and what are the level of rise in last few decadal scale, or even in centuries scale, like 100 years, 200 years? So that are the what are the records, and how it is concerned to us. So that's why I think we need to have this trend you can please present. And third one, so what about this national level vulnerability atlases? Is it getting updated or being updated or not? So that is my concern. So thanks, please answer these queries. Thank you.
Thanks for your question, sir.
Yeah.
The first one, whether we can stop sea level rise, to best of my knowledge, no. Even if we stop emitting greenhouse gases right next moment, because we are talking about sea level rise in reference to anthropogenic induced climate change.
Yeah, that's why I told minimize. I told sir minimize, not stop.
Yes.
We can minimize,
Yeah,
reduce.
minimize.
Yeah.
Okay, minimize, reduce. I don't think it is not possible, because even if we stop emitting the greenhouse gases, whatever we have emitted so far, that has its own influence in melting the glaciers and thermal expansion. So the minimize of sea level in near future, I don't think it is possible. We will certainly experience the rising sea level, at least for the next few decades. That's
Because
answer
Kyoto Protocol, so many protocols are
Second
being
one,
yeah, so many climatological
but we have not achieved Kyoto Protocol.
Yeah, right.
We neither achieved the Kyoto Protocol nor the Paris Agreement. So we failed actually.
Yeah.
And we are still struggling for it. So sea level rise is going to happen for sure, at least for the next few decades, undoubtedly. And next, there are definitely standardized methods to measure the past sea level trend. I just gave tide gauge data as one example. As you rightly said, there are satellite altimeter, and there are so many methods every day it's coming up. Even last week also, this USGS has come up with a new method of measuring the observed sea level trend. There are methods, but in Indian scenario, our what method we are using, it depends on the station's observation. Not every station is having satellite sensors. Certain stations are traditional tide gauge stations only. And also the data, if you see the PSMSL, those that platform receives data from Survey of India. So whatever the tide gauge station from India, they send the data to Survey of India. Those data are then transferred to PSMSL. They have some data gap. In case of Tamil Nadu, there are 4 stations you can see in PSMSL. Out of 4, like one in Tangachi Madam, another is Tuticorin, then in Chennai, and there's one more. Out of these 4, only in Chennai you have 100 years of data. You ask for a century or decadal data. 100 years only we have data with a data gap. Whereas other 3 stations, we have just 12 years or 18 years. There is one philosophy. If you want to study about the past sea level trend with the help of tidal data, one need to have at least minimum 20 years of tidal data. Then only you can plot a graph. If your data is below 20 years, it cannot be taken into consideration. In that phenomena, out of these 4 stations, Chennai alone have more than 50
100
to
years.
80 years data with
Yeah.
the data gap. Hello.
Hello.
I'm sorry, it got disconnected.
Yeah, right.
Can I continue?
Yeah, please.
Yeah, so decadal data we do have for certain stations. In connection to that question, in the past few years, whether it has been increased or not rapidly, globally, yes. It has increased the sea level rise when we compare to 2 decades before, and within this 2 decades, the sea level has increased rapidly, and we have number of peer-reviewed papers just answering to your question. Yes, it has increased. With reference to local level, that we need to investigate. Whether it has been increased in Tamil Nadu, East Coast, that we need to best of my knowledge with the PSMSL data, it is not that alarming.
Kindly unmute.
I'm actually sorry, it is going break with my internet connection.
Anu?
Yes, sir.
Yeah. Yes, sir. Saleem, sir, you can continue.
Yeah, so we do have a sea level rise has been increased. Globally, we have evidences, but locally we need to explore. What is the third question, sir? I just give me a hint.
Third question is that vulnerability index and vulnerability atlases, is it being updated national level regularly
Yes,
or not?
Actually, I'm not the right person to answer this question. I don't belong to the government, and I am not a spokesperson for the government. But by my understanding, I think NCSM has doing some good job of updating the vulnerability index and vulnerability map, in particular for the coast. They are coming up with a line called hazard line across the coast of entire India. So that act as a one of the guiding line for us to take.
Yeah, thank you. So I think this hazard related information also need to be a concern and to be public domain, so that the user agency, even the researchers and this public can have this access, so that they should able to means wisely handle this coastline in plantation of mangroves, casuarina, and even this coastal barriers like that sea mount, sea walls, all these things. hope all these will able to
Yes, sir.
means stop this sea level rise, at least to means prevent the means bad incidences or maybe flooding, cyclones and other disasters. Thank you.
Yes, sir. You're very much right. I endorse you and I am with you. I'm waiting for the same data to explore further.
Yeah,
Thank you, sir.
thank you very much.
Thank you, sir.
Any other questions, Anu?
No, sir.
No.
Sir,
Yeah, Jay Kumar. Yeah,
Jay Kumar,
please,
sir.
actually, the last question from the participant, no, I can answer, sir. Actually,
Yeah, please.
vulnerability index mapping, atlases is talk about. It is available, sir. Disaster Management Authority of India, they are preparing it, and each state also preparing under. It is undergoing, sir. You will be get within a year, sir. The project is going on,
Thank you. It will be
sir.
useful, very much useful
Yeah.
for users and researchers.
It will be available within a year, sir. All the state will be upload their concern websites as well.
Yeah, it is very much essential. Thank you. Thank you.
Thank you. Okay.
Thank you, Dr. Jay Kumar.
Thank you, sir.
Thank you, Jay Kumar, sir.
If there is no questions, we can conclude the session now.
Yes, sir.
Thank you, Saleem sir. And it's very interactive. Thanks for your presentation. Anu, now we can give the.
Yes, sir. Sure, sir.
Yeah.
For participants regarding tomorrow's session, the talk is on climate change and science communication by Professor Dr. S. Nagaratnam, Chairperson, Department of Communication, Madurai Kamaraj University. So kindly join the session at 6 p.m. tomorrow. Thank you all.
Thank you, Dr. Saleem sir.
Yeah.
Thank you.
everyone.
Thank you, Vivekanandan sir, and thank you, Seshatri sir, and thank you, everyone.
Thank you.
Thank you.
Thank you so much, sir. Thank you so much.
Thanks, sir. Thank you.